Okay, so thanks again, Waseem and Amleto, for volunteering to present the result of your research in this webinar series. I won't steal any further time to you, so please tell us about this practitioner perspective on design, monitoring, and testing of microservices.
Thank you so much, Jyoti. I'm honored to have a chance to speak in Microservices Community Research Webinars series. My name is Mohammad Waseem, and I'm here along with Dr. Amleto to present our recent work regarding design, monitoring, and testing of microservices system. This is, we recorded the practitioner perspective from 29 countries, and I will gradually explain our key findings regarding design, monitoring, and testing of microservices. So these are the outline of my presentation today. Because this is one of the long paper, we only present our research method, results, research implications, and we can discuss some future research planning as well. So first of all, I will introduce what are the microservices and why these are important and what kind of challenges we can face during the design, monitoring, and testing of microservices system. Recently, the software industry has witnessed a growing popularity of microservices. Architecture style is a promising design approach to develop applications that consist of multiple small, manageable, and independent deployed services. Microservice, basically architecture, allows building a complex application as a set of modular component or services. And the number of services, intercommunication processes, different kind of dependencies, instance of microservices, network communications and their protocols, and other variables influence design and development of microservices-based system. Microservices architecture styles bring unique challenges for software organization, and many quality attributes may be positively or negatively influenced. So there is a growing body of literature that investigated different aspects of microservices architecture style. One notable research area is how to migrate monolithic system to microservices architecture. Despite these efforts, it is little empirical known how the software industry design, monitor, and test microservices system. These three aspects play a significant role in succeeding with microservices system. For this study, our aim to gain a deep understanding of how microservices systems are designed, monitored, and testing in the industry. So this was our main goal, aim of the study. So this goal we have distributed in three research questions. The three research questions are originated from this goal. First of all, we investigated how microservices systems are designed in the industry. The second question was regarding how microservices systems are tested in the industry. And the third question was regarding how microservice systems are monitored in the industry. For example, to answer the research question one, we asked 17 service the question regarding team structure, questions, application structures, the implementation strategy, architecting activity, design description methods, quality attribute, design patterns, architecting skills, challenges, and solutions. Similarly, to answer the research question two, we asked 6 survey questions regarding monitoring metrics, monitoring practices, monitoring tools, challenges, and solutions. Research question 3 also investigated by asking 6 survey research questions regarding testing strategy, testing tool, skill, challenges, and solutions. To achieve our goal, we used mixed method studies. Basically, we conducted survey and interviews. To conduct survey, first we actually perform 2 systematic mapping studies regarding testing, design, and of a microservices architecture, and also we get some data from the gray literature. So we prepared the survey instrument by using our systematic mapping studies and gray literature. Once our systematic survey instrument was ready, we conducted the pilot survey. And after completing our survey instrument, we reached to the audience and we conducted a survey, and we sent nearly 9,000 emails to participants, and we got 136 responses, and out of 136 responses, only 106 responses were valid. So the valid responses we analyzed by using statistical techniques and grounded theories. And finally, we report the result. Similarly, to get deeper insight into the survey result, we conducted interviews. We prepared the interviews instrument by using the survey results. Mainly, we identified the reason for the key findings. And again, similarly to the survey instrument, we also pilot the interview instrument. We selected the participant and we conducted the interviews, and we analyzed the interview data by using MaxQDR tool and thematic classification theory. So finally, we report our key findings. Now, I will explain some of the key results regarding this study. We have distributed survey results in the 4th section. First, in first section, we will present the demographics of the survey. Second, design architecture of regarding the design. Third is regarding the monitoring, and fourth is regarding the testing of microservices systems. So again, we only present the key findings and some of the research implication that can be explored further. So basically, as I mentioned, that we have sent the 9,000 emails, around 9,000 emails to microservices practitioners, and we got only 136 responses. Among those, 106 responses are valid responses. So the majority of the practitioners from the Asia, nearly 65.5% of practitioners from the Asia. And the survey participant responsibilities, they have multiple responsibilities, but mainly they are related to the application developer, architect, DevOps engineer, and database developer. So, regarding the status of microservices adoption across the organization, we found that 59.5% of organizations use the building sum of apps, and similarly, 26.4% organization using microservices application architecture for all apps, and 14.1% of organization does not use any architecture style, microservices architecture style, but the participant had the knowledge of microservices architecture. Similarly, regarding the experience of the respondent in the IT industry, so we found that average experience, 38.7% of the participant had 3 to 5 years of experience in the industry, and 59.4% of participants had the 0 to 2 years of experience regarding development of microservices-based application. About organization size, we found that around 50% of more than 50% of organization had the employee size from 21 to 500 employees, and similarly, the people working on one microservices, we found that 43.4% of people, 2 to 3 people are working on one microservices, and 4 to 5 people are working on microservices in 27.4% of organizations. Regarding the domains of the software system, mainly they are related to e-commerce, professional services, and financial services. And regarding the software development methodology, we found that most of the organizations are using agile approaches, but mainly we found that they are using a Scrum or development for microservices development. So now I will present some of the key findings regarding design of microservices system. The first our question was regarding the strategies of application decomposition into microservices. So we asked the participants how they are dividing, they are decomposing application into microservices. So most of the participants said that they are using a combination of, basically they're using a combination of domain-driven design and business capability to decompose application into microservices. And to get a deeper understanding, we asked the interviews the reason behind why they are using combination of DD and business capability. So all of the interviews confirmed that the result of the survey reflect the actual use of application decomposition strategies in the industry. 5 out of 6 interviews also confirmed that they are not familiar with any other kind of approach that can be used for application decomposition. 4 interviews mentioned that several reasons for using a combination of domain-driven design and business capabilities. Like they said, a single strategy cannot meet the application decomposition goal in a good way. And also they mentioned that it supports the creative and iterative collaboration process between system stakeholders like technical expert, domain expert, and customers to achieve the decomposition goals. And they also said that it is suitable when implementing microservices architecture in an agile or DevOps processes. Meanwhile, they also mentioned some reasons like it provides the controlled flexibility for future changes as most of the changes remain around the particular domain. And also it reduced the misunderstanding because requirements are gathered from a specific domain perspective. Finally, they mentioned that this combination also provides a better team communication because all of the stakeholders use a shared set of terminologies. So these are the few reasons that I mentioned here regarding application of combination of DD and business capability for application decomposition into microservices. So our another question, one question regarding strategies from the design to implementation of microservices system. So the majority of respondents mentioned that they only design only high-level design for major microservices. Again, to understand the reason behind this finding, we asked the interviewees what are the possible reasons behind this kind of result. They mentioned that, for instance, 4 interviews mentioned that high-level design is enough to visualize the identified microservices and their major functionalities. So it also shows communication and orchestration style between microservices. They also indicate scalability point for each microservices, and it is fine for identifying insecure point in microservices system. So these are the few reasons that I mentioned for only high-level design for microservices system. So one question regarding design of microservices system, we asked a question about architecting activities, mainly regarding architecture analysis, architecture synthesis, architecture evaluation, architecture implementation, and architecture maintenance and evolution. So basically, we get the agreement of the respondent. We ask mainly they are strongly agree, neutral, or disagree regarding this finding or not. So our result indicate that the survey respondent pay more attention to architecting activities that are close to solution space. For example, architecture evaluation, architecture implementation, and architecture maintenance and evaluation. Regarding describing the microservices in the industry, we ask how the practitioner, what kind of strategies or method they are using for describing architecture. So most of the participants said they are mainly using boxes and lines, UML and UML diagram. So this is basically semi-informal methods or semi-structured formal method they are using. So again, we asked the similar question regarding the frequent use of informal and semi-formal description methods. We summarized some of the responses of all the interviews. For example, they said we are choosing because interactively visualize or describe several views of the system for stakeholder. This also provide a visual representation and flexibility to changes. And this also these techniques are also low cost and easy to learn, and they provide a quick implementation and maintenance in the documentation. Also, they said the learning curve for these approaches are a bit easy, and it is easy to understand and communicate in an effective manner. So some of the we also consider that some design component of microservices, like they are normally using services and domain services processes for describe the architecture, and most of the diagram they are flow chart, use case diagram, data flow diagram, activity diagram, and sequence diagram. and also class diagram are using to describe the different view of the microservices architecture. And the next question regarding the next two questions was regarding the microservices design patterns and the importance of the quality attributes. So majority of the participants said they are using normally API gateway, backend for front end, access tokens, and database per service. These patterns are very often, or oftenly they are using this pattern. So we recorded the some of the reason for this token. For example, we asked about why they are using access token very frequently instead of any other protocol. So about the frequent use of security pattern like access token, our interviews mentioned several reasons such as token-based authentication allowing an application to access an API one-time login. No session is preserved on the server side. Stateless regarding the frequent use of database per service pattern. And 6 interviews mentioned provided the 4 reasons for the database per service pattern. They said this pattern helped to design and develop the loosely coupled application, provide support to the selected database according to the requirement of each microservices, help to control the changes for failure by limiting them to the specific microservices. So we identified this kind of reason, and the more detail is available in our paper. Similarly, regarding the quality attribute, the importance of quality attribute, majority of result said that indicate that security, availability, performance, scalability, and reliability are the most important quality attribute. So again, in the paper, we also recorded the several reasons for each pattern. For example, why the security is important. They said, okay, this is the microservices are distributed applications. So that's why this is very important to keep the, this is very important when we are designing the architecture of microservices system. So the final 2 questions regarding this part was about challenges and the solution for the challenges to design of microservices system. Basically, we provide the 10 candidate answers to the participants regarding the design of microservices system. So majority of participants said that the clearly defining the boundaries of microservices system, addressing security concerns, and managing microservices complexity at the design level are very critical challenges. And these challenges also have an impact on monitoring and testing of microservices. So different responses are recorded here. So these are the different challenges that we have identified through our empirical study from the practitioners. So most of the priority, the frequency against each pattern is recorded here. And we found the solution for some of the challenges. For example, some of the strategies, pattern and domain-specific languages can be used to address some challenges to some extent. For example, domain-driven design pattern can be used to clearly define the boundaries of microservices system according to the responses of participants. And similarly, like microservices API patterns and structured design pattern and circuit breaker patterns can be used to address some other challenges. Again, we did not find the solution for all challenges for identifying, for addressing a microservices design. So here I will present a research implication for regarding this part, and after that I will hand over this presentation to Amleto, and after Amleto presentation again I will present the testing part. So regarding the research implications, so these are the some of the research implications that can be explored further. For example, we said that the future empirical studies seek the guidelines that detail how to break a monolithic into microservices using the DD and business capability strategy together. So here, if someone is interested, they can investigate or they can propose the guidelines for a combination of DD and business capability strategy for application decomposition. Research is needed to empirically investigate the necessity, understandability, and actual use of microservices architecting activities in the industry. And we also suggest further research about the pros and cons of using informal description method for describing microservices architecture. Moreover, it is also interesting to investigate how formal description methods For example, domain-specific languages or architectural description languages can be adapted to describe microservices architecture in the industry. And again, there is still a lack of knowledge of state-of-the-practice security techniques and tools, as well as their potential security vulnerability, which deserve an in-depth empirical investigation. So for now, that's it from my side. Now I will request to Dr. Amleto. He can proceed his part.
Okay, thanks, Waseem. Okay, as already said by Waseem, in our survey concerning the monitoring aspects related to microservices systems, we defined 6 questions about monitoring metrics, practices, tools, monitoring challenges, and their solutions. So first of all, concerning monitoring metrics, the idea was to first of all we specified what is a metrics. They are values measured over intervals of time. So the data, the gathered data that we use it for that that someone uses for measuring them. Generally come from hardware, software, and infrastructure resources, and also they come from running systems. So having this in mind, we defined a question containing 13 monitoring metrics that we identified from the GRI literature, and we asked the practitioners, what are the used metrics? So the participants replied that the most popular monitoring metrics is resource usage, more or less 67%, followed by load balancing and availability. And then in the interviews, we asked a question in order to understand the reasons behind using these monitoring metrics. So the interviewers, of course, confirmed that they mainly use these metrics such as resource usage, load balancing, and availability. And but they also added some other hints. In particular, they say that these metrics are useful for example, to provide better customer experience or monitor the availability state of the system from the end user perspective. So, and also they use it for from an how to say, financial point of view. In particular, they use to estimate the budget, and it is particularly important when the microservices system uses, for example, a cloud, and this cloud can cost. So it's quite important to monitor how many virtual machines or containers are running, and so on and so forth. Concerning the monitoring practices, okay, we identified 6 monitoring practices from GRI literature. In particular, we highlighted we identified the log management, exception tracking, health check API, log deployment, audit logging, and distributed tracing tracking. So the participant mentioned that the first 3 practices are the most often used. In particular, for log management, they use very often, and often at least at most 60–80%, and followed by exception tracking, and then health check API. Also, in this case, we asked something to the interviewers in order to understand the reasons behind the reasons why these monitoring practices are frequently used. They replied that monitoring practices are useful for help to perform the root cause analysis for specific issues and other stuff. Concerning the monitoring tools, please. Okay, we identified 13 monitoring tools gathered from the literature, and many participants indicated that Jira and the Datadog Kafka dashboard are the monitoring tools that they used, and also Spring Boot Actuator. So in order to better understand why the practitioners specified Jira as monitoring tools, we defined a question within the interview, and the main result is that the practitioners have a different understanding of Jira as a monitoring tools for microservice systems. For example, 3 interviews suggested that Jira is in general integrated within the not only the integrated development environment, but within all the development tools used for implementing the system. So in this way they consider the Jira as a tool to monitor the development of microservices system. And also other 2 interviews consider Jira as part of the monitoring microservices system. Okay, then other 2 questions in our survey are related to challenges faced during the monitoring of microservices systems. And in this case, we collected these challenges from academic and degree literature, and the most, I would say, important challenges of monitoring microservice systems from the practitioners perspective are collection of monitoring metrics, data, and logs from containers, and the distributed tracing. Concerning the proposed solution for these monitoring challenges, we received 24 answers from the survey and the interview. And we considered only 12 answers as valid. We excluded the solution the solutions that were incomplete or inconsistent or that don't are adequate to our as a response. So and the participants recommended 10 tools. For example, the LAK stack, Elasticsearch, Logstash, and Kibana, and in particular this solution, this I don't know, maybe okay, we can define as a platform. In this solution address the challenges number 1 and 4 and 5, and also they recommended Prometheus and Spring Boot Actuator, Grafana, and Zipkin, as Zipkin is a distributed tracing monitoring tool. So concerning the research implication, okay, we have 4 research implications. The first one is related to monitoring metrics. And our idea is to propose some empirical studies about monitoring practices and tools for application metrics. And one other idea would be to empirically validate taxonomies for microservices issues, and another study could be to empirically investigate the need, understandability, and actual use of monitoring tools in the industry. And the last one is related to develop and empirically evaluate the solutions for addressing the challenges that we highlighted during our survey, such as having many components to monitor, performance monitoring, and distributed tracing. Now, Waseem can conclude the presentation by highlighting the testing part.
Thank you so much, Dr. Amleto. So again, the third part, the final part regarding to our study was about testing of microservices systems. So again, we provide some candidate answers to the participants, and basically we have conducted another systematic mapping studies in which we identified the several approaches and tools, challenges, and that we have used to investigate from the practice. So according to the responses, the top 3 most frequently used testing strategies are unit testing, end-to-end testing, and integration testing. Again, similarly to other questions, we asked about the reason for using the top 3 strategies. All of the interviews were familiar with these testing strategies. They also acknowledge that they frequently use these testing strategies to test microservices system. According to the interviews, these are fundamental testing strategies that can be used for all types of system. For example, MSA-based system, service-oriented based system, or even monolithic system. Concerning the reason for concerning the reasons of unit testing, all of the interviews mentioned that they were used the strategy because unit testing allow isolated testing of the design component of microservices system, makes sure each microservice is working correctly and delivering the required functionalities, help to identify the problem with individual microservices in the early stage of the system development. So we also asked about the reason using integration testing strategy. According to the responses, they said that integration microservices together verify that microservices are working collaboratively to achieve the business goals. And also they said the communication path between microservices system are working correctly or not. And a third party APIs and microservices system are working together as expected. Finally, we ask about the reason for the end-to-end testing. These are out of 6 interviews, 3 out of 6 interviews stated that they are typically perform end-to-end testing for testing the whole microservices system. So the next question was regarding the testing tools. So again, we identified these tools and some other tools from the Gray literature as well as from the systematic peer review literature. So the large number of participants responded that they used JUnit, JMeter, and Mocha tool for testing their applications. Regarding JUnit and JMeter, all of the interviews agreed that these are the fundamental testing tools that are required to test Java-based application, including microservice-based applications. Those microservice-based applications that are using Java as application development tool. Moreover, 3 out of 6 interviews also mentioned that these tools include Mocha also provide efficiency, simplicity, and agility in testing of microservices system. So again, we recorded several reasons about some other tool as well in our paper. So our one question was regarding the skills required to test microservices system. We identified several skills, and again, we confirmed from the practitioner. They said, okay, writing good integration testing test cases, writing good unit test cases, knowledge about multiple database, etc., is one of the key skills for microservices testing. So regarding the research implications, we found that we concluded that end-to-end testing can cause several challenges in the testing process, such as delivery delays, generation bugs that are difficult to isolate, and liability conflicts, etc. Researcher can investigate how to provide solution for these kind of challenges. So this is one of the research area that researchers can be work on it. The survey and interview results indicate a need for more investment in testing tools specific to the microservices system. So we found that the most of tools are, for example, can be used any kind of system. So hardly we found some specific tool for testing a microservices systems. We collected several testing strategies, approaches, and guideline as solution to address the respective challenges. However, these solutions are not enough to address all microservices testing challenges. So these are the few of research implication. Again, detail is available in our paper, and we will provide the link of our paper. And finally, I will use opportunity. Here I will finish my presentation, but still I have something to share with the microservices enthusiastic. So I will share some of our papers that have been published in last 2 years regarding microservices architecture. This study, this is a systematic mapping study that has been published in a Journal of Software and System in December 2020. So it's again very detailed study, and currently is one of the highly cited paper in JSS. So our another paper in which we have identified automatically a security discussion in microservices system. Again, this paper is published in a Journal of System and Software. This is an industrial survey and experiments, and we have used the several machine learning approaches and the training models to identify the security discussion and several kind of security issues for the microservices system. This is another testing systematic mapping studies that was published in Asia Pacific Software Engineering Conference. It's about testing microservices architecture-based applications. And one more paper that we have published in EASE in 2021 is about on the nature of issues in 5 open source microservices system. This is empirical study, and we have provided one of the comprehensive taxonomy of microservices issues and their causes as well. And in 2021, we also published another paper. It's about a decision model for selecting patterns and strategies to decompose application into microservices. This paper was published in the ISOC conference. And in this year, our paper has been accepted in ICSI. It's about decision model for selecting patterns and strategies in microservices system and their evaluation by practitioners. The preprint version is available on ResearchGate, and interested one can be downloaded from there. And this paper basically present the empirically evaluated decision models for application decomposition, microservices security, application microservice communication, and service discovery. So this is a very interesting paper, and interested microservice enthusiastic can be downloaded from there and can read it. So here I will finish my presentation, and now any kind of question regarding our presentation is welcome.
Thank you, Waseem and Amleto, for your talk. So, as Waseem has anticipated, now it's time for question, in case there are. So while the audience is thinking about possible question, I may make one.
Yeah.
So well, I have more than one, but one is on the process that and on the method that you applied. Yeah. Because you showed that most of the practitioners that you were interviewing were not that expert in microservices, right? Because they were developing microservices in 0 to 2 years. I mean, when you show, yeah, that in these slides. So in the development of microservice systems, they were not that expert. So did you consider kind of weighting the answers, or I don't know, like making a projection of the answers based on only on those that have more experience? Or is just the overall thing?
No, actually, as I mentioned that most of the participants had the microservices experience, but again, they were majority of the participants had the experience for up to 2 years. So our question, like very explicit, we ask a very explicit question, and yes, indeed, we found several answers that was not logically cannot answer. They were not reasonable, and that clearly show that this this guy or this potential participant had no experience in microservices. Definitely, we excluded those answers. Indeed, we comprehensively analyze all the questions, and after that, if we got some valid response that is logically and that can be we included those. And also, we also excluded some of the answer of few participants. For example, if one guy, there was a 39 question. For example, if one guy answered very correctly, like 35, 34 or 35%, then we assume that this guy have experience microservices, have experience with microservices. If he or she had they cannot correctly answer to more than 5 questions, we didn't included his response. So we clearly mentioned in our paper this criteria as well.
Okay. Okay, thank you for this clarification. And I mean, if there is any question from the audience, please raise your hand. In the meanwhile, I may make another one, which is still at a very high level. So in the research implications that you show, most of them were on still classifying on using empirical software engineering approaches to like distill knowledge from what's available in the information from the practitioners. But what about the other way around? So what can we do for practitioner to help them in their daily life with microservices? So what are, in your opinion, the most promising research directions in which we can make kind of solution proposals for them to use, so to say?
Yeah, for example, apart from this study, as you may ask me a general question, based on our understanding by conducting empirical studies. So mainly, if you provide some generic guidelines to the participants, they're more interested in it. For example, we got this kind of responses from our recent study that has been accepted in EXE. So we provide a detailed decision model. So for example, these decision model are regarding a selection of patrons and the impact of the patron on quality attribute. So these are empirically, they can visualize easily. For example, one participant, developer mentioned to me, he said that, okay, I just provide this model to my team. They can easily now trade off between the decision. If we are using this decision model for application decomposition, then we have this kind of impact. So negative impact, positive impact on application decomposition or not. So this kind of studies can be conducted. Here, for example, as I mentioned that, so a guide about the guidelines, how to break a monolithic into microservices using DD and business capability. As far I know, I did not see any study, maybe to the best of my knowledge, that provide the guidelines for combination of domain-driven design and business capabilities to the practitioners. So if someone is interested, what they can do it, they identify the practices from the practice and then validate their practices in the practice. And after that, they can propose some generic guidelines to the practitioner. So they can have some starting point. So similarly, some other areas can be investigated.
Okay, thank you. So we now have a question from the audience by Antonio. So Antonio, please.
Hi, everybody.
Hi.
Yeah, actually, I have a question on this very slide. Maybe Mohammed mentioned that and I missed it. But my question was on point 2, no? Why do you say that, in what sense, what do you mean when you say that we need more research to investigate the necessity of MSA architecting activity?
Yeah, this was very interesting. For example, these architecting activities are clearly mentioned in my paper, but due to the time constraint, I cannot present everything here. So, for example, most of the architecting has been investigated in context of monolithic systems. These are the traditional architecting activities, as I mentioned. So here, I got the responses. Most of the participants say neutral, like this. Did not clearly answer our question. So we said that, and I did not find in the literature that where explicitly we found that necessity, understandability, and actual use of architecting activity in the industry in context of microservices system. So that's why I mentioned here. The result of the reflecting that they are not much familiar with that explicitly. Probably we are, because of the terminologies, they are not familiar. So that's why this is one of the our proposed area.
Okay, thank you. You're muted, Jacopo.
Jacopo, turn on the microphone.
Sorry. I was saying that I don't see any other raised hand, so I think we can stop here. And let me thank again you for volunteering and for presenting your research to us. We will provide all the necessary information on YouTube, so that if people is looking at your presentation and wishes to contact you, they can do it.
Okay.
Okay, thank you so much.
Thanks.
Thank you.
Thank you so much, everyone.
You keep us. Okay. Thanks
Thank
a
you.
lot.
Bye-bye.
Bye.
Thank you. Bye.